Hello! Today, we're going to explore a fundamental concept in mathematics, exponents. By the end of this video, you will be able to understand what an exponent is, apply the various laws of exponents to simplify expressions, and see how exponents are used in scientific notation. Let's start with the basics. What does an exponent actually mean? An exponent is a shorthand way to write repeated multiplication. It tells you how many times to multiply a number by itself. Let's look at an example. Consider the expression 2 to the power of 3. In this expression, the large number, 2, is called the base. The small, raised number, 3, is the exponent. The base is the number being multiplied, and the exponent tells us to multiply the base by itself 3 times. So 2 to the power of 3 is equal to 2 times 2 times 2. And if we calculate that, 2 times 2 is 4. And 4 times 2 is 8. So 2 to the power of 3 equals 8. Let's try another one. What about 5 to the power of 2? Here, the base is 5 and the exponent is 2. This means we multiply 5 by itself 2 times. 5 times 5 equals 25. So 5 to the power of 2 is 25. You might also hear exponents referred to as powers. For instance, 5 to the power of 2 can be called 5 squared, and 2 to the power of 3 can be called 2 cubed. These are special names for exponents of 2 and 3. So to recap, an exponent is a powerful tool for writing repeated multiplication in a compact form. The base is the number being multiplied, and the exponent tells you how many times to multiply it. Now that we understand the basic idea, let's explore some special cases and properties of exponents. First, let's talk about the zero exponent rule. This rule states that any non-zero number raised to the power of 0 is equal to 1. This might seem a bit strange at first. Why would multiplying a number by itself 0 times give you 1? Let's look at a pattern to understand this. Consider the powers of 2. We know 2 cubed is 8, 2 squared is 4, and 2 to the power of 1 is 2. Notice the pattern. To get from one power to the next lower power, we divide by the base, which is 2. 8 divided by 2 is 4. 4 divided by 2 is 2. If we continue this pattern, what should 2 to the power of 0 be? It should be 2 divided by 2, which is 1. This pattern holds true for any non-zero base. So whether it's 5 to the power of 0 or 100 to the power of 0, the answer is always 1. For example, 5 to the power of 0 is 1, and 100 to the power of 0 is also 1. Next, let's talk about the negative exponent rule. This rule states that a base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. Let's extend our pattern of powers of 2. We have 2 to the 1 is 2, and 2 to the 0 is 1. Following the pattern, we divide by 2 again. 1 divided by 2 is 1/2. So 2 to the power of negative 1 is 1/2. Let's try another one. What is 3 to the power of negative 2? Using the rule, 3 to the power of negative 2 is 1 over 3 to the power of positive 2. We know 3 squared is 9, so the answer is 1 over 9. So a negative exponent doesn't make the number negative, it makes it a fraction. It's a way of saying 1 divided by the positive power. Now let's move on to the rules for combining exponents through multiplication and division. First, the product rule. This rule says that when you multiply two powers with the same base, you add their exponents. Let's see why this works with an example. Consider 2 squared times 2 cubed. We can write this out. 2 squared is 2 times 2. 2 cubed is 2 times 2 times 2. So we have a total of 5 2's being multiplied together. This is the definition of 2 to the power of 5. Notice that 5 is the sum of the original exponents, 2 and 3. This confirms the rule. Let's try another example. What is x to the power of 4 times x to the power of 7? Using the product rule, we keep the base, x, and add the exponents, 4 and 7. The result is x to the power of 11. Next, the quotient rule. This rule says that when you divide two powers with the same base, you subtract the exponent of the denominator from the exponent of the numerator. Let's use an example to understand this. What is 3 to the power of 5 divided by 3 squared? We can write this as a fraction. In the numerator, we have 5 3's. In the denominator, we have 2 3's. Just like with regular fractions, we can cancel out common factors from the top and bottom. We can cancel 2 3's from the numerator and 2 3's from the denominator. We are left with 3 3's in the numerator, which is 3 cubed. Notice that 3 is the result of subtracting the exponents, 5 minus 2. This confirms the quotient rule. So 3 to the power of 5 divided by 3 squared is 3 to the power of 5 minus 2, which is 3 cubed. Let's try one more. Simplify y to the power of 8 divided by y to the power of 3. Using the quotient rule, we subtract the exponents. 8 minus 3 is 5. The answer is y to the power of 5. We have 2 more important rules to cover, the power rule and the power of a product rule. First, the power rule. This rule applies when you have a power raised to another power. It says you multiply the exponents. Let's see why. Consider the expression 2 cubed squared. The outer exponent, 2, tells us to multiply the base, which is 2 cubed, by itself 2 times. So we have 2 cubed times 2 cubed. Now we can use the product rule we just learned. We add the exponents. 3 plus 3 is 6. So 2 cubed squared is 2 to the power of 6. Notice that 6 is the product of the original exponents, 3 and 2. This confirms the power rule. Let's try another one. Simplify x to the power of 5 to the power of 4. Using the power rule, we multiply the exponents. 5 times 4 is 20. The answer is x to the power of 20. Finally, let's look at the power of a product rule. This rule applies when you have a product of 2 or more numbers inside parentheses, and that entire product is raised to a power. It says you can distribute the exponent to each factor inside the parentheses. Let's take the example 2 times 3 squared. The exponent 2 tells us to multiply the base, which is 2 times 3, by itself 2 times. So we have 2 times 3 times 2 times 3. Because multiplication is commutative, we can rearrange the terms. We can group the 2's together and the 3's together. This gives us 2 squared times 3 squared. This shows that we can distribute the exponent to each factor. Let's try a more complex example. Simplify 3x squared y cubed to the power of 4. We distribute the exponent 4 to each factor inside the parentheses, 3x squared and y cubed. Now we simplify each part. 3 to the power of 4 is 81. For the variables, we use the power rule and multiply the exponents. For x, we have 2 times 4, which is 8. For y, we have 3 times 4, which is 12. So the final answer is 81 times x to the power of 8 times y to the power of 12. Let's put all these rules together and work through a more complex example. Our goal is to simplify the expression 2x cubed y to the power of negative 2 squared, all divided by 4x to the power of negative 1, y to the power of 5. We'll tackle this step by step. First, let's simplify the numerator. We have 2x cubed y to the power of negative 2 squared. We use the power of a product rule to distribute the exponent 2 to each term inside the parentheses. This gives us 2 squared times x cubed squared times y to the power of negative 2 squared. Now we simplify each part. 2 squared is 4. For the variables, we use the power rule and multiply the exponents. For x, 3 times 2 is 6. For y, negative 2 times 2 is negative 4. So the simplified numerator is 4x to the power of 6, y to the power of negative 4. Now let's rewrite the entire expression with our simplified numerator. Our expression is now 4x to the power of 6, y to the power of negative 4, all divided by 4x to the power of negative 1, y to the power of 5. Next, we can simplify the coefficients. 4 divided by 4 is 1, so they cancel out. This leaves us with x to the power of 6, y to the power of negative 4, divided by x to the power of negative 1, y to the power of 5. Now we use the quotient rule for each variable. We subtract the exponents. For x, we have 6 minus negative 1. For y, we have negative 4 minus 5. Remember that subtracting a negative is the same as adding a positive. So 6 minus negative 1 is 6 plus 1, which is 7. Negative 4 minus 5 is negative 9. Our expression is now x to the power of 7y to the power of negative 9. Finally, it's good practice to write our answer with only positive exponents. We use the negative exponent rule for the y term. Y to the power of negative 9 becomes 1 over y to the power of 9. So our final simplified answer is x to the power of 7, all divided by y to the power of 9. Now that we've covered the rules, let's see a practical application of exponents, scientific notation. Scientific notation is a way to write very large or very small numbers in a compact form. It's widely used in science and engineering. A number in scientific notation is written as a product of two parts. The first part is a number between 1 and 10. The second part is a power of 10. Let's look at a very large number. The distance from the Earth to the Sun is approximately 150 billion meters. That's a lot of zeros to write. To convert this to scientific notation, we need to move the decimal point to create a number between 1 and 10. The decimal point is currently at the end. We move it to the left until it's between the 1 and the 5. Let's count how many places we moved it. We moved it 11 places. This number of places becomes our exponent. Since we moved it to the left, the exponent is positive. So 150 billion meters can be written as 1.5 times 10 to the power of 11 meters. Much simpler. Now let's look at a very small number. The diameter of a hydrogen atom is about 0.00000000010 meters. Again, a lot of zeros. This time, we need to move the decimal point to the right to get a number between 1 and 10. We move it until it's between the 1 and the 0. Let's count the places. We moved it 10 places. When you move the decimal to the right, the exponent is negative. So the diameter of a hydrogen atom is 1.06 times 10 to the power of negative 10 meters. This is a perfect example of why we needed to learn about negative exponents. The exponent in scientific notation tells you the order of magnitude of a number. It gives you a quick idea of how big or small the number is. Let's quickly recap what we've learned today. We started by defining an exponent as a shorthand for repeated multiplication. We then explored the zero exponent rule, the negative exponent rule, the product rule, the quotient rule, the power rule, and the power of a product rule. We saw how these rules allow us to simplify complex expressions and how they are essential for working with scientific notation, which is used to represent very large and very small numbers. To help you practice, here are 2 homework questions. First, simplify the expression. 3x squared, y to the power of negative 3, cubed, divided by 9x to the power of negative 1, y to the power of 4. Second, write the number 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 Thank you for watching.